Children, let us continue the chapter Circles. Now let us take the 7th question. If diagonals of a cyclic quadrilateral are diameters of the circle through the vertices of the quadrilateral, prove that it is a rectangle. So it is given that in a circle with center O, ABCD is a cyclic quadrilateral and AB and CD are its diagonal, which are the diameters of the circle. So you take the solution. In the figure, ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. Diagonals AB and CD are intersecting. So you take they are the diameters of a circle and also you know that as they are diameters, therefore you can write AB equals DC and also you write AO equals OB equals CO equals OD because they are the radii of a circle. Now here what you have to prove? You have to prove that ABCD is a rectangle. You know that it is a quadrilateral. It is a quadrilateral in which the diagonals are equal and diagonals bisect each other. Here at a point O, they bisect each other. Therefore, you write here as AO equals OB equals CO equals OD. You can say that diagonals bisect at a point O. Diagonals bisect at O. And also you can say that all the angles of the quadrilateral are 90 degree as they are the angles in the semicircle. Here AB and CD are the diameters, means all the 4 angles of the quadrilateral ABCD are right angles. So you take angle CAD equals angle ADB equals angle CBD equals angle ACB, all are equals to 90 degree. They are the angles in the semicircles. Angles in the semicircles as AB and DC are diameters. Therefore, here what we can conclude? Here ABCD is a quadrilateral in which the diagonals are equal, diagonals bisect each other and also all the angles are right angles. Therefore, we got that in the quadrilateral ABCD, diagonals are equal and bisect each other. Diagonals are equal and bisect each other and all the 4 angles are equal. All the angles are equal to 90 degree. Angles are right angles. Right angles. Therefore, we can say that ABCD is a rectangle. ABCD is a rectangle. Here got all the four angles are equal to 90 degree. Diagonals are equal. It is given, and diagonals bisect each other. Now the question number 8. If the non-parallel sides of a trapezium are equal, prove that it is cyclic. So it is given that ABCD is a trapezium and its non-parallel sides AD and BC are equal. Then it becomes isosceles trapezium. So you write solution here. Given that, or in the figure, ABCD is a trapezium. ABCD is a trapezium in which AB parallel to CD. AB parallel to CD and non-parallel sides, and you write and non-parallel sides AD equals BC. Therefore it is isosceles trapezium. Here ABCD is a trapezium. As its non-parallel sides are equal, it is an isosceles trapezium. So in a trapezium, if non-parallel sides are equal, then it is called isosceles trapezium. And here you know the property of trapezium and also the special property of isosceles trapezium. Then what is the property of trapezium? In trapezium, angles at the ends of the non-parallel sides are supplementary. Means angle A plus angle D equals 180 degree, and also angle B plus angle C is 180 degree. And also one thing, you know, as AB is parallel to DC, here angle A and angle D are the angles on the same side of the transversal, interior angles on the same side of the transversal. These two are also interior angles on the same side of the transversal. Angle A and angle D are the interior angles on the same side of the transversal. Similarly, angle B and angle C are the interior angles on the same side of the transversal. The sum of these two angles is 180 degree. Similarly, sum of these two angles is also 180 degree. And also you can take, or the property of, according to the property of trapezium, angles at the ends of the non-parallel sides are supplementary, means their sum is 180 degree, that you can take. And one more property, that is the special property of the trapezium, that angles at the ends of the parallel sides are equal. So here you will get angle A is equals to angle B, and also angle D is equals to angle C you will get. So you write that angle A plus angle D equals 180 degree. You can take that in trapezium, angles at the ends of non-parallel sides are supplementary. And also you can write angle A plus angle A is equals to angle B. Angle A is equals to angle B, that is in isosceles trapezium angles at the ends of parallel sides are equal. Then in the place of A you write B. Therefore you can take angle B plus, so you take this is second, this is first. Angle B plus angle D equals 180 degree, that is from second. Here you substituted in the place of A, you wrote B. So B plus D, angle B plus angle D is equals to 180 degree. So you got that sum of one pair of opposite sides are right side 180 degree, and you know that the angle A plus angle C must be also 180 degree. That is, you know that angle A plus angle C plus angle B plus angle D is equals to how much? 360 degree. So you write this is third 360 degree, because here sum of angle sum property of the quadrilateral, angle sum property of quadrilateral, that is sum of four angles of a quadrilateral is 360 degree. So you write in the place of angle B plus angle D you write 180 degree, angle A plus angle C plus 180 degree equals 360 degree. So you can take angle A plus angle C equals 360 degree minus 180 degree equals 180 degree. Otherwise you can use the same property to prove this also. So you can use any one of the method. So you got that as opposite angles are supplementary, means as the sum of opposite angles of the quadrilateral is 180 degree or this trapezium is 180 degree, you can say that this trapezium is a cyclic trapezium or cyclic quadrilateral, as the sum of opposite angles of trapezium ABCD is 180 degree. It is cyclic. Now the ninth question. Two circles intersect at 2 points B and C. Two circles intersect at a point B and C. Through B, two line segments ABD and PBQ are drawn. Through B, there are two line segments. One is PBQ and the other one is ABD. This line. They intersect the circles at A, D and PQ. They intersect the circle at A, D, P and Q. Here PBQ intersect the circle at B, P and Q, and ABD intersects the circle at A and D. So we have to prove that angle ACP equals angle QCD. Angle ACP equals angle QCD. That you have to prove. Angle ACP equals angle QCD. Now how you can prove this? Here you know that These two angles are in the same segment of the circle. Angle ABP and angle ACP are on the same segment, are in the same segment of the circle, so they must be equal. And in this circle also you observe these two angles, angle DCQ or QCD and angle DBQ are in the same segment, so they must be equal. So you take that. And also these two angles are equal. Why these two angles are equal? They are the angles which are at the common vertex and opposite each other, which are called as the vertically opposite angles. So here you got that these two are equal and these two are equal and these two are also equal, and naturally you can get these two are equal. Here the things which are equals to the same thing are equal to one another, that you can take here. So you solve it, take the solution and you write that here what is given in the figure. In the figure, two circles intersect at 2 points B and C. Two circles intersect at B and C. ABD and BBQ line segments ABD and PBQ intersect at ADPQ. Now you write these two angles are equal. Angle PBA equals angle ACP. And also here you write angle QCD equals angle DBQ. Give the reason, same reason. What is that reason? Reason is they are the angles in the same segment. So write the common reason for this, angles in the same segment. Angles in the same segment. And also you write angle PBA angle PBA is equals to angle DBQ. So this is the first one, this is the second one, and this is the third one. Here PBA is equals to DBQ and also is equals to ACP. So here you can take ACP must be equals to PBQ. ACB must be equals to PBQ. That is from here first, second and third. Right? From the first, second and third. Here in the first you got that PBA equals ACB. In the second you got that QCD equals PBQ. And third you got that PBA equals PDQ. Here we have to prove that these two are equal. And consider here these two are equal and this is also equals to this one. So all the four angles becomes equal here. Therefore you write all the four angles first you take from first, second, third, right? So from first, second and third you write all the angles here. Angle PBA equals angle DBQ. DBQ equals angle, here DBQ is also equals to QCD, and this PBA is also equals to, you write start from here ACP, you start from ACP, angle ACP equals angle PBA, PBA is equals to angle DBQ, DBQ is equals to what? QCD. Here ACP equals PBA, PBA is equals to DBQ, DBQ is equals to QCD. Therefore you can take, therefore angle ACP equals angle QCD. All the four angles are equal, you got here, and these two are equal. Now let us take the 10th question. If circles are drawn taking two sides of a triangle as diameters, prove that the point of intersection of these circles lie on the third side. Here AB and AC are the diameters of the circle and they are the two sides of a triangle ABC. And we have to prove that the point D lies on the third side BC. Here we have to prove that the point of intersection of these circles lie on the third side, and this D is a point of intersection of the two circles. We have to prove that D lies on BC, means BDC is a straight line, that we have to prove. So you write the solution. In the figure, AB and AC are the diameters of two circles and they are the sides of triangle ABC. Then D is the point of intersection. D is the point of intersection of two circles. We need to prove that D is a point on BC. That is BDC is a straight line, that I have to show. It is very simple to prove. Let us join AD. Let us join AD. Here AD is joined. Now you know that this angle ADB is 90 degree because it is the angle in the semicircle, as AB is a diameter. Similarly, angle ADC is also 90 degree as AC is a diameter of the second circle. And 90 plus 90, 180 you will get. So they will get angle BDC equals 90 plus 90 equals 180 degree. Then it is a straight line. So write angle ADC, write angle ADB first. Angle ADB equals 90 degree and angle ADC equals angle ADC equals 90 degree. The reason you write angles in the semicircles. In the semicircles, as AB and AC are diameters. AB and AC are diameters. Then the sum of these two angles, angle ADB plus angle ADC, angle ADB plus angle ADC, that is 90 plus 90. So ADB plus ADC, you will get BDC, that is angle BDC equals 180 degree. So BDC become a straight line. Therefore BDC is a straight line. Straight line, and D lies on the side BC, which is a, so take D lies on BC, which is a third side of a triangle ABC. Third side of a triangle ABC. Here this is the third side, as AB and AC are the diameters of the two circles, and D is a point of intersection which lies on the third side of the triangle ABC. Children, let us take the 11th question. It is given that ABC and ADC are two right triangles with common hypotenuse AC. Prove that angle CAD equals angle CBD. Now you consider the two right angle triangles ABC and ADC. Here AC is the common hypotenuse. Now let us draw the circle with AC as a diameter, and let us join BD. So you write the solution. Here ABC and ADC. ABC and ADC are two triangles with common hypotenuse AC. Let us draw a circle with AC as a diameter, and join BD. Here what you have to prove? We have to prove that angle CAD equals angle CBD is to be proved. You know that they are the angles in the same segment. So directly you can write angle CAD equal angle CBD. They are the angles in the same segment. They are the angles in the same segment. They are the angles in the same segment. So you got that angle CAD is equals to angle CBD. Now the 12th question, prove that a cyclic parallelogram is a rectangle. Now let us consider a cyclic parallelogram ABCD whose vertices A, B, C and D lies on the circle. Now you write that Solution. ABCD is a cyclic parallelogram whose vertices A, B, C, D lies on the circle. We have to prove that ABCD is a rectangle. You know that in the parallelogram opposite angles are equal, and in the cyclic quadrilateral opposite angles are supplementary, means their sum is 180 degree. Equal and their sum is 180 degree means all the four angles are 90 degree. And here in the parallelogram, if all the angles are right angles, then it becomes a rectangle. So you take in the parallelogram ABCD, right angle A equals angle C. Reason, opposite angles of a parallelogram are equal. Opposite angles of a parallelogram are equal. And also you know that angle A plus angle C equals 180 degree because it is a cyclic quadrilateral. Opposite angles of, or you write sum of opposite angles of quadrilateral is 180 degree. So you take, this is the first, this is the second. They are equal and their sum is 180 degree. Therefore you can have that from first and second you can have angle A equals angle C equals 90 degree. Angle A equals angle C equals 90 degree. Similarly you can have angle D equals angle B also equals to 90 degree. So you write similarly angle B equals angle D equals 90 degree. Here also the sum of B and D is 180 degree and they are equal, so they must be equals to 90 degree. As all the four angles are equals to 90 degree, you can say that ABCD is a rectangle. Therefore, as in the parallelogram ABCD, all four angles are -90 degree. It is a rectangle. So you got the proof that cyclic parallelogram is a rectangle. Therefore you write, cyclic parallelogram is a rectangle. Cyclic parallelogram is a rectangle.